In this video, we're going to be talking about how rainbows are formed, how sunlight shines through raindrops and get bent and reflected outwards into our eyes to form the bow that we see. Now, when the sun shines light into a raindrop, the raindrop is fairly spherical. And what happens is the light is traveling through a certain medium. The medium is air, and then it enters the water droplet. Now, as light enters a water droplet, it slows down. And there's all these different colors of light: red, orange, yellow, green, blue, indigo, and violet. And all of them have different properties. The red is the lowest energy, which has the greatest wavelength and the lowest frequency. The violet has the smallest wavelength and the highest frequency. So on the extreme ends, the red one gets bent slightly, it breaks out, it gets dispersed, goes to the back of the water droplet, comes down, and then gets released from the droplet that way. Now, when the violet light or the purple light interacts with the water molecule, because it's higher frequency, higher energy, it happens to interact more with that water molecule and therefore gets bent more. So it gets bent more as it enters the water droplet, and then it comes out above the red. Okay, and all the other colors sort of fall in between. So I'm just going to show you the extremes from the red to the violet, and then all the oranges, yellows, greens, blues, and indigos are going to fall in between the red and the violet. Now, it turns out that this red is actually going to hit our eye at about 42 degrees. And the violet is actually going to go right over our line of sight. So we actually can't see the violet from this drop. So if we have a second drop, it's going to look sort of similar, where the red comes in and then comes out. And then where the purple comes in, the violet gets bent a little bit more and then goes outward. Now, that's where we actually see the violet light. We see the violet light from a different droplet of water. So there's millions and millions of droplets of water. So it's obviously not necessarily two, but it's going to be one from below. So we view the violet light at about 40 degrees. And then between that 40 and 42 degrees, again, that's where the orange, yellow, green, blues, and indigos fall into place. And then that's where we see all the different colors of the rainbow. That's why the violet part is at the bottom of the rainbow, right over here. And then the red part is at the top of the rainbow. Now, typically, when we see the arch of a rainbow, we see half of it, but it's actually a complete circle that's being blocked by the ground. Now, if we view the entire rainbow, there are many, many 42-degree angles. So if we're standing back in this field and then viewing this rainbow, we can see all of these red stripes at 42 degrees and all of this purple stripe at 40 degrees. And as I said, that rainbow actually completes a full circle, which you'd only be able to see if you're flying in a plane or skydiving and you're at the right place at the right time. You will be able to see a full circle. Now, if you see below the rainbow, it's actually fairly bright, and above it is fairly dark. Now, the light doesn't actually just bounce around this cleanly and then only have one of each color. The light is coming in from all kinds of different angles, so it's being released at all kinds of different spots in the water droplet. Now, where it comes out most prominently is the stuff that I'm showing you in the picture. Okay, but it's actually kind of being sprayed all over the place. Now, it turns out that below the violet, all of the light is getting bent and mixed up below the violet, which creates the white light below the rainbow. And none of that light, or excuse me, not none of it, but a lot less of the light gets bent outwards beyond that red. So then it's going to be much dimmer above the red. Now let's talk about the double rainbow. If you see in the picture here, there's a faint double rainbow over here, and then that's because as the light comes in, it comes in at a slightly lower angle right around here. And then same thing as before, the red and the violet get broken up differently. So for the double rainbow, the red hits down here, comes up here, it then gets bent out. And then for the violet, as usual, it gets bent a little bit more. It then comes out this way. So because of the multiple reflections within the droplet, you see that the red is on top and the violet is at the bottom, which is the exact opposite of our original rainbow. That's why for the second rainbow, if you were to see one, the red is on the bottom and the violet is on the top. And there's not too much contrast between the bottom of the second rainbow and the top of it, but like our primary rainbow, it's much later on the bottom because everything is reversed. For our second rainbow, it's going to be slightly brighter on top of our second rainbow because of how the light is reversed because of the multiple reflections on the inside. So, to recap, we have some dispersion going on right over here, which is where all the colors get broken out from the original ray of the sun. And then as they get broken out, they are refracting, which means that they are bending as they're entering that water droplet. And because all the different colors of light have different frequencies and different wavelengths, they interact with that water droplet a little bit differently and then come out as the different stripes of the rainbow that you see it. So I hope that was educational and helpful to you. Thank you for watching and listening.